So the endocrine system is the study of our hormones that are molecules that rule and rock our world, right? And keep us in homeostasis, because the nervous system is telling the endocrine system what hormones to produce when, right? So let me say this, and I think maybe y'all just trust me. I'm telling you this because it's a good heads up. I've been here, I've seen it, I've done it. The people who don't do well on this endocrine cardiovascular beginning here don't make it through the course. Even though the rest of the semester is the easiest part of AMP, because the rest of the semester we will continue to talk about those hormones. So if you didn't get them in the beginning, what I see is that people don't get them the whole way through and they don't make it. So I'm encouraged. The reason I'm saying it the way I'm saying it is because I need you all to start off strong, right? And in this first 2 or 3 weeks, if you all get this information, and when I say get it, do I mean memorize it? No, if you memorize it, you need to get out of this field. And all I can tell you is that's a fact. If you're memorizing, you're not owning it, you can't critically think about it, and you don't want to be in the medical field. It is the only profession where no errors are accepted. And you all know it. You all know that, don't you? And it's unreasonable, because of course errors are made. Of course we're only human. And of course medicine is one of the toughest things that you could possibly be doing, because every single day we're behind on what we're finding out. Right? And every single day for any particular disease, no two people who have the disease are going to respond the same way. But you know what? And you think about this like it's you or your family member that you're treating. You want them to have you want to be in the moment, you want to be mindful, you want to be making sure that you are trying to avoid anything that can go wrong, that you have responsibility over. And that responsibility is that you know this information well enough that you could teach it. Because here's what we know about critical thinking. If you could teach something, then you've owned it. So that's your goal in learning. And while you're in this classroom, in this foundation class, because it's just a foundation, but this foundation class, you do not want to be memorizing ever. You want to be taking the information and thinking, how would I explain this to somebody? How could I explain it in 5 different ways that they could maybe understand it at the end? Because if you know it well enough like that, when you get to the next level, you're going to be thanking me. But not just that, you're going to really be thinking, yeah, I get this, I understand this, I understand the complexity of this, and that's all okay. And that's all okay. Anyway, so I really want you to understand that, I gave you kind of a tentative schedule of what we'll be doing in here. Sometimes things go a little bit faster than others, so we can play a little bit with it. But I spend a lot of time on the endocrine system because, honestly, if you don't know that, you really can't go forward. So hopefully you all are going to carve out in your crazy busy lives. I know they are, and whatever, but you're going to carve out the time that you can devote to this for the next couple of weeks. That type of standard, okay? Are we good? Do you have any questions about that? All right, so you all know that your grades come from quizzes, lecture quizzes that you have every day unless there's a test schedule. And sometimes you have a lecture quiz and a lab quiz that morning, right? So you know that. You know that being here is part of the battle for most people. Because most people, if they can stay engaged when they're in here, can make this powerful for them. You should have read the chapter. Y'all should be savvy enough at this point that you have read or looked over chapters before you get in here, because you'll know that the way I teach is not by reading to you. I try to teach by application and telling you like how this connects with this and how this has happened, how this happens, right? So that will make that much more powerful if you've read ahead, and you can devote the time you need to, especially in these first few weeks. Any questions? The labs, good news about the labs, there's no bones and muscles that you're going to be doing. The labs in this part are actually, except for lab 1, the labs in this part are strictly labeling anatomy. So I could show you a picture of the 10 major endocrine organs, just 10 little organs, right? And that's going to be lab 2. But all the labs after that, they're really just labeling structures. You won't have word banks, and spelling will count, but it's usually going to be very, very kind of basic in these organ systems we're about to go through. Nothing like all those bones, nothing like all the muscles. So the lab portion of your grade should help you significantly in here. All the lab quizzes, I will announce at least a week before we have them. So with that being said, let me tell you that next Tuesday you'll have your lab 1 quiz. And your lab 1 quiz, y'all are going to, some of you are going to think, oh, this is awesome. Some of you are going to think, damn, I didn't get the first time. I don't want to do it now. So anyway, but look, excuse me, but okay, I'll do it on the phone. All right, look, but I do want you all to know that the first lab is going to be really a repeat of the lab that you all had in AMP1, and it's that important. The first lab, it's not going to be exactly the same lab quiz. Of course, I'm going to do different questions. But the first lab quiz for you is going to be directional terms, regions of the body, knowing the correct term, the medical term, as well as the common term. Do y'all remember that lab? And this is what you're going to know. Now, I'm going to talk more about it at the end of today during that time. I'm going to give you all some things that I want you to look at in your textbook this time. You also have a visible body, but I'm going to be more specific, and we're going to talk more about it. And y'all just need to revisit that. When you revisit something, it's another way of solidifying the information in your head. So I really need for you all to be very, very comfortable with all of that. So it will be your first lab quiz in here. The second lab quiz will be labeling those 10 major endocrine glands that we are going to talk about in the endocrine system. But anyway, so labs are really anatomy. When I say anatomy, what does that mean? It's knowing that if you saw something, even if it was dissected, even if it was disarticulated, like the bones that we all had, you could pick that thing up and say, this is an ear, right? Or you could pick this structure up and say, that's the lens of an eye, right? You remember that? Then you just dissected those eyes, or you could pick that structure up and say, this is a liver, right? And this is the orientation of the liver. This is the anatomical, this is the anterior aspect, this is a lateral, this is an inferior view, this is a superior, this is a posterior view, right? Right? You know all those terms. There's a first lab we're going to have. But you would be able to pick out something, and from the way it looks, its structure, you know its name. And you also know where it should be located in situ, where it should be. Is everybody alike as far as where their kidneys are, or where their liver is, or where their heart is? We'll learn where the heart we can typically think about where the heart is. But is everybody the same? So, but in anatomy, we learn the names. By looking at we look at the structures, we become so familiar with them that we learn their names, but we know where they should be also located, right? So that's anatomy. What's physiology? It's knowing the function of that structure. Why do we study anatomy and physiology together?
The structure dictates function.
Thank you. Y'all got that down. Structure dictates function. Right? Right? Like we wouldn't use a hoe to rake our yard, would we? Because the structure of that hoe is just not going to work out for us, is it? But how about a rake? Its structure. Will that help us rake the yard? No, we don't. But anyway, you get what I'm saying. It's the same absolute thing in anatomy and physiology, whether it is botany that you're looking at or whether it's human anatomy and physiology. Whatever you're studying, structure dictates function. Just at a macroscopic level, at a gross anatomical level, what's gross anatomical level means? What you can see with your naked eye. Is it just at that level that structure dictates function? No. We know it happens at what other level? Cellular level, really? Cellular level? And inside of cells, cells are the smallest things that are alive, right? Y'all would remember that. They're the smallest things that are animated and have life, and we talk about the properties of life. But how about inside of cells, where you find things that aren't alive, but are necessary for life? How about inside cells? How about their structures? How about the structure of a mitochondria? Does it look the same as a Golgi? No. Does a Golgi look the same as centrioles? Do centrioles look the same as endoplasmic reticulum? No. The structure dictates what? Even inside at a non-living level with these organelles. Is that right? Wait a minute. What are organelles made of? Organelles are not alive inside of cells. Inside of cells. I just named a few, didn't I? What are they made of? Yeah, big molecules that are made of smaller molecules. So molecules are made of atoms. And so the structure of an atom might dictate, even a structure of an atom. Yes. Atoms of elements that are the smallest things that we know that have unique properties. Even the structure of them, those tiny little things can dictate how they function. Yeah. And why was that important to do that at that level? That at that level, what is making up all life, all cellular life, is made of non-cellular life. Atoms that make molecules, that make up bigger molecules, that make up organelles, that make up our cells. But why was it important that we know their structure? Why are we looking at their structure? Why do we care that their structure dictates their function? Why do we care?
Because when it's wrong, that's where disease starts.
Say that really louder.
Because when it's wrong at that level, that's where disease starts.
That is where disease happens, is at that level. So can you really understand, well, we can't even understand normal physiology, but could you possibly understand disease unless you knew that, right? So we've already gotten past our foundation in molecular and cellular biology, but hopefully, I was thinking if I brought anything in here, but hopefully you are always keeping in mind that the newest research you're reading about, when you guys are reading about immunotherapy, and you're reading about all the things that are going on with diagnostic medicine right now, where is that happening? At a molecular level inside the cells. That's exactly right. So this is why we care to stay up all the time with this and to understand that and never kind of forget that. But then we said these cells come together to make up tissues. Cells come together, y'all don't remember this hierarchy for the first quiz that we're going to have soon, like Thursday morning at 9. So cells come together to make up what? Tissues. And how many types of tissues are there? Four basic categories of tissues. I want you to name them. Name those. Epithelial, connective, muscle, and nervous. Now, within those categories of tissues, cells make up those tissues. And there's more than 200 different kinds of cells. So there's quite a few categories in those 4 types of tissues. But yes, those tissues have very special kinds of functions. You know, we didn't just categorize them because we like to name them. We like to label things. We categorize them because they have certain things in common. They have certain cells in common. And we know that when somebody has a particular disease, at what tissue level it occurs, right? Because if we know that, then we know, again, this is going to help us to understand how you're going to have to go about treating. It's all about learning normal so that we can understand abnormal and then understand why we're treating something the way we treat it. All right, so 4 tissue types, 2 or more tissues come together to make up organs. Give me some examples of organs. The liver, the heart, the intestines, the stomach, right? Your tongue, right? So these are organs, and organs come together to make up whole organ systems. And in this chapter, with this section, we're starting with the endocrine system, and it is a system of organs that supply many of the body's hormones. I want you to define a hormone as something that's a molecule. So a hormone's alive, No, molecules aren't alive, are they? Cells are the smallest things that are alive. But cells produce these molecules that we call hormones, and these hormones are molecules that are going to elicit a response. And sometimes the same cells, sometimes neighboring cells, and sometimes far-reaching cells. So hormones are these molecules that can turn reactions on or off in their target cells. I can hardly wait. How about you guys? Right? Is this right? To understand and intuitively get what a hormone does, where it's released from, where it's going to target, and what's going to happen when it gets there. Your goal in the next week or so is that for every hormone you hear the name of, you know where it's released from, you know where it's coming from, which means its origin. Right? Sometimes people will say to me, well, I didn't know what you were asking. What does that mean, origin? It means where it came from. Where was it released? So you'll know every hormone we talk about, you'll know where it was released from. You'll know that where it targets, if it's a specific target. Some hormones are widespread and they target many cells, most cells. But some hormones are incredibly specific in where they target. Do you think you would need to know that? Yes. And for every hormone you hear, you'll not only know where its origin is and where it targets if it's specific, but you'll know what it does when it gets there. What kind of function it's going to have once it gets to that target. Wouldn't you think that would be important to know? Yes. And let me tell you what else you're going to know intuitively by critical thinking, if you know that. If you know that. Not if you memorized it, because if you memorized it, you won't be able to think next past the dot on the sentence. But if you really know that, let me tell you what you're also going to know. You're going to know why the body releases it from that origin when it does. You're going to know why. You're going to know what the stimulus for the release of it was. And that's your goal, guys, for this whole chapter, is that any hormone you hear, you know immediately where it's coming from, where it's targeting, what its function is when it gets there, and why you released it when you did. Fair enough? And if you know, which is more than memorizing, if you know that, then you're going to know why that person has the signs and symptoms they do of that disease, because that hormone level is actually not where it needs to be, hyposecreted, or why they have the signs and symptoms they do because there's a hypersecretion. Do you get what I mean? See, to me, that seems like, okay, well, that's good. Because I get it, why I put the effort in right there. I can see why I need to know this to know this, right? And sometimes all we need is that motivation to understand that. This is not a class, I know I tell y'all this all the time, this is not a class where you cross a T and dot a I. This is a class that's a foundational class of your profession. And you got a lot of family members who will be looking at you, not just your patients. Do y'all just treat your patients? Mm-hmm. No. So this is our motivation for being in here. I'm going to try to, and we're in it together, so I really, truly am going to try to do everything I can to help you all with this. Okay, so we know we have lab quizzes that you will have a week's announcement before the lab quiz comes. Other than the first lab, all of them are going to be just seeing a structure and labeling it, right? I can tell you that none of the labs in here are going to have, very many structures that you would have to be labeling. So my God, let this help you. Okay, let this grade help you. Come in here ready for those lab quizzes, knowing how to spell the structures, knowing where they're located, knowing what they look like, because that's just anatomy. We started studying that before we could verbalize. Then we could pat our head before we could say it, right? So good. That's your lab part of the grade. The tests are going to be the multiple choice tests. It's going to be probably at least 5 multiple choice tests. The tests are going to be the most significant part of your grade. Those multiple choice questions will come from lecture, what we talked about, said out loud, discussed in here. They will come from your deeper insights in your textbook. If you don't know where those are yet, whatever, just make sure you don't leave today until you know what I mean when I say deeper insights. And the test questions will come from your disorders or diseases of those organ systems, those tables at the end of each chapter. Most of those disorders we have talked about too. Yeah, but even if we haven't, will you be making notes on them? Right, you're knowing basic things. Like, is this disorder a hypersecretion or a hyposecretion? Right? And this disorder is a disorder of which organ? Right? And so if you knew that and you've learned the hormones, you should also know what signs and symptoms of that disorder is, because you've learned what that hormone's function is. So let me say this, that's very different from A&P1. Y'all ready? It's very different from A&P1. The final exam in this class, on the last day of this class, the final exam, y'all know the final exams are usually just disorders and deeper insights, right? So if you've been studying those as we go, that your final exam is just a review. Your final exam in this class is 100 questions, and at least half of the final exam is, guess what? What are these? Hormones. Hormones. Questions about hormones. Is that going to be incentive for you to get them now?
Yes.
Mm-hmm. Any hormone, any question, let me say this, any question about any hormone that we have already talked about will always be fair game in this session from this point on, even on lecture quizzes. So in 3 weeks from today, when we are doing, in 3 weeks from today, when we might be looking at the lymphatic system or the respiratory, I don't know, but wherever we are, and I give you 2 questions on that lecture quiz that was about a hormone, will that be a fair question? Okay, so I hope I've instilled in you that you have got to get these now. Fair enough. No lab quiz grades no lab quiz grades or tests get dropped. So if you miss a lab or you miss a test day, a day that we're having a lab quiz or a day that we're having a test, you must, I really strongly encourage, try to work with y'all because I know how busy y'all are. I strongly encourage you all to be in my office an hour before the next class period. If you don't know where my office is, find out before you leave today. And you take that before the next time we meet. Fair enough? Is that fair enough? Okay. Because anything that you're pushing off too far, it's just overwhelming for you. It becomes overwhelming. So again, part of the battle is being here, being present, but also is being up to date. It is a lot easier to keep up than to catch up, isn't it? Mm-hmm. It's hard to catch up. All right, so yes.
Are we going to be doing study guides?
Yes, if y'all want those.
Yes.
Okay, so yes. So reminder is that after this is being recorded, so y'all, I don't know what the percentage is. I would say it's probably less than 20% of you all ever go to recordings. But each lecture is recorded. I have a couple people who have to be out sometimes, and so just because of their work schedules and whatever, and they email us. So listen, but they would do the recordings, but I think it's probably less than 20%, but it's available to everybody, the recordings, when they work. But I also, at the end of the lecture, each day, I'll put up on Canvas, because it's on Canvas, I'll put up the dates so that you, as a discussion, so you can click on that discussion, click reply, and then put in 10 study guide kinds of points or questions that you would do. You can do them either in question form with the answers following. Or, I think that's the best way to do them. And only do 10. Only do 10. Once you hit submit, anybody who's done it before you, you would be able to see their study guides. So you won't be able to see other people's study guides until you put in your own, until you contribute. And so that will be up usually by the afternoon of the date that we had lecture. So you would want to do that before the next lecture period, because you could maybe use people's study guides to see how complete the notes were. Please take the effort to be accurate in what you are putting up. Please, 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 because this is a participation thing. It is 5 points though, so of your final grade. So y'all should want to do this, because it also, you're encouraged to do it. You're given some credit for doing it, even if you didn't get any points, but you are getting points, so do it. Please spell correctly, Okay. So be accurate in your study guides and spell correctly, and I don't want more than 10. And the reason being is I do think that some people will just wait and look at errands and think, they're my notes. She would have done study guide or so complete. Okay, thanks, Aaron. I got my notes. So don't give away all your good stuff, but definitely make a study guide that helps you in the process, but also helps you to look at others. Okay. Good? Any other questions? Those were all good questions. I didn't know if I did the study guide again, but I will. All right. We remember lecture quizzes are filling in the blank, defining, sometimes describe, and answer. Lecture quizzes are only about 10 questions. So again, sometimes y'all will come in here and you will have learned a lot. But the lecture quiz might not reflect it, just because you're not in control of what questions are right. And so sometimes you can get discouraged. I think sometimes when people come in and they think, but I really thought I knew this, and I really, I studied the wrong things. Is there any such thing as studying the wrong things? No. Don't ever tell somebody you studied the wrong thing. You can study incorrectly. I do think that's true. I think you can learn, you can look and date and glaze at something for hours and not have picked up anything. Because if you didn't see it exactly the same, you wouldn't know it. That's memorizing. And is that learning for critical thinking? It is not. It is not. So I do think that that's possible. So, but in the watch and the long run, it will come through if you're doing the right kind of study. I will drop at least 4 lecture quiz grades. So you can be out. That's a significant amount of time. Days lost. I'm not saying don't be here for 4 days, but I'm just saying you could be. It wouldn't hurt you on a lecture quiz, because I'll drop at least that many. You could be late or absent 4 times, and it not hurt you. Or you could just maybe not be prepared 4 times, and it won't hurt you, because there will be times that you won't be able to be prepared, and I understand it. And you should understand it and give yourself a break on it, right? Some of you are way hard on yourself. I mean, you really are. You're very hard on yourself, and you need to get over that, because you should congratulate yourself for just being here. It took a lot, and don't think I don't know it. All right, so are we ready? We've already started a little bit, haven't we? We've already started a little bit of this. I'm obviously not ready. I don't have a PowerPoint up. Y'all have any other questions? Jump yeah. All right. Let's see.
No questions for me while I'm bringing this up? No? Did somebody say whatever? Who said whatever? Did somebody say that? Because I would like to know the whatever. I would like to know that. Okay. So this is a view of the major endocrine organs, and So you can sort of see this endocrine man slash female gonads here showing this. So ovaries, testes, and then some of the other major glands. We're definitely going to be looking at all of those. Now, obviously, on lecture quizzes, do I ask you anything we hadn't talked about? So that's how you focus your study for those lecture quizzes, because I try to give those to you that way. And when I said that when you think about hormones, you have to learn normal. You have to learn what's considered to be a normal response, because then if you see a hyposecretion, which means low, then you'd understand why, and why the signs and symptoms you see. Or if you see a hyper, and it's going to be important for each disease that we learn in the endocrine system, that you know whether it is a hyper or hyposecretion, if that's what the disorder is. Is it hypo? Is it hyper? What's causing it? Is it autoimmune? Do you think that would be important to know if something was autoimmune? Yeah. So it, or maybe an inherited type of thing, or endemic, just meaning environment is causing it. So we'll want to know causes. We'll want to know exactly what's being presented, hypo or hypersecretions. And so those are the kind of things we want to know when we hear about disorders. But we do have to learn normal first. So our concentration is on learning what's normal first. There are 10 major endocrine producing organs that are part of the endocrine system. But hear me when I say this. Every cell in your body is an endocrine cell, except for red blood cells. So you all told me that we have over 200 different kinds of cells that make up 4 tissue types. And I'm telling you that every one of those trillions of cells minus the red cells are endocrine cells? Yes. So in this foundation information, we're going to learn the basic hormones. But let me tell you something about endocrinology, the study of the endocrine system. Endocrinology. A specialist would be called what? Yes, an endocrinologist. Let me tell you something about this study. We are like cave people in our understanding. You're going to think, God, there's nothing else we could find out. Wrong. Almost every day, either a new hormone is being discovered, almost every day, or a hormone that we've known about for decades, that we were pretty sure we knew what it did, even if it had multiple functions, we're pretty sure we knew what it did. We're discovering new things that they do that we didn't know about. Is that going to be important to realize that we are really just on the cusp of understanding the endocrine system? And the reason that we know already how important it is because we learned about something called homeostasis. And what was homeostasis? Who would like to tell me in their own words how they would tell the rest of us peers? We're all peers in here. The rest of us, what you feel about what homeostasis means. What is homeostasis? In your own words, a state of balance, but what does it really mean to you? It means that you as an organism, as an individual, standing kind of alone as an organism, are always being exposed to environments that are changing. The environment that we started with this morning, sitting in this room, is it the same as it is right now? Or has the temperature been going up and down? And you know, believe it or not, lights are flickering, sounds in the hallways are changing. You within your own body, internal environments are changing. So what does that mean to you? It means that something better be sensing that. Why? Because if something is sensing always the environmental changes that are always happening, the environment never stays the same. So the environment's always changing. It means that your nervous system, composed of nervous tissue that is detecting these changes, are sending signals predominantly to what system? The endocrine, to keep you in a state of balance, as Julie said, and Lauren, a state of balance, meaning that when something gets a little high, that's okay, it will be detected, and that level will be brought back down to stay within set point.
And when that same level gets a little low, that's okay. It will be detected by what system? Nervous system, sending signals to the endocrine to bring it back up, keeping you in a state of balance. What was that feedback called that we said that mainly keeps you in homeostasis? What was that feedback called? It's called negative feedback. And it's happening. The autonomic nervous system is controlling this with thousands of different parameters at any given second throughout your life to keep you in a state of balance, a state of homeostasis. And it's wonderful that that nervous system's able to set the set points and define a range so that when something gets a little high, there's specialized cells that are detecting it. When it's a little high or a little low, sending signals to the endocrine system mostly to keep you in homeostasis. It's wonderful that that's happening. But without the nervous system responding to those signals, would you ever be able to be in homeostasis? No. So these two systems, the nervous system and the endocrine system, arguably, I mean, these are the ones that you just really got to know and understand. So this is where we are. We do understand that we will learn the basic hormone. We will learn most of the more common hormones, but this is just our foundation, right? This is just our foundation. We're understanding that even some of the hormones that we're learning about, we're going to be probably hearing more about them in the future. Okay, so this is why we're in here. Any questions for me about that? So this is another picture of endocrine man, female, you know, with the gonads. So this is another picture we'd like to look at. When we're looking at the anatomies of these organs, do we want to just look at one picture? No, you want to look at these organs, like try to isolate them out. They would look like if they were laying dissected, disarticulated on the table. You want to be thinking of it, looking at as many pictures as you can. You don't want to just look at anterior aspect, do you? You want to look at this thing from the top, which is called, from the bottom, from the side, lateral, right? Okay, so you want to be looking at these from every different type of situation, and that's how you learn where they are, and you learn what they look like, and then you also learn where they should be situated. So we're definitely, that's how we're going to approach this. Now, we had learned some prefixes. Did we say there's any such thing as a big word? And, you know, sometimes in medicine, we can hear this language. It seems like a foreign language, doesn't it? How many of you have had medical terminology? That's awesome. Okay, so in medical terminology, you all learned that there are no big words. They're just prefixes, root words, and suffixes. And their meanings don't change, the prefixes, root words, and suffixes. And we just kind of, but it can seem like a foreign language. It can seem kind of daunting. But if you're learning it as you go, then it becomes kind of second nature to you, and you end up understanding this. So when we think about exocrine glands versus endocrine glands, what this just means, glands are, we know, are secretors, so they secrete products. Exocrine glands are going to secrete products into ducts. These ducts are going to take those products, and typically they will eventually exit the body because of this ductwork system. And along the way, they're certainly going to be having functions along the way. Some of the functions are going to be, like, for example, food digestion. You know what? Your 30-foot alimentary canal, your digestive tract, that 30-foot tract from your mouth to your anal sphincter, that 30-foot, that's a big duct, isn't it? I mean, that's really all that is a big duct, usually. But then we have other smaller ducts like sweat glands, sweat ducts, and those types of things. But yeah, they're going to serve functions. Endocrine glands that we're going to mostly concentrate on in this section are going to be those glands that are releasing their products into the fluids of the body, usually through the bloodstream. So that's going to sort of make us understand that, wow, our blood needs to be transported appropriately, right? Because blood is carrying all of these and very vital types of hormones. That's one of the things that the blood is actually delivering. We already knew that blood did so many things, didn't we? We already knew that blood has your red blood cells that are delivering gases, right? Oxygen to our tissues and delivering CO2 back to our lungs. And we knew we had white blood cells that protect us. Is that right? But now we know that there's another thing, there's another purpose for blood moving through the body, and that's to deliver these endocrine hormones. So if it's endocrine, it means it's going to stay within the body. So very good. Now, as far as this, how they relate to each other, that's just FYI. When I say something's FYI, doesn't mean you're not to read it. You should read over it. But am I going to test you on it? I'm not going to test you on it, but it certainly does help to maybe look at it and see it. So anyway, I'm going to go through some of this. Now, I had talked to you all about the hypothalamus when we were looking at the nervous system, right? And when we looked at the brain, we did a mid-sagittal section of the brain. Do y'all remember the mid-sagittal section of the brain? All right, so this is actually a cadaver. And before I go to this, let me go back. Let me go back to this little illustration. We don't get enough time that I think I can just go to actual cadaver dissections to look. I think the illustrations sort of help you to see it. So you see this man, and we're looking at a lateral view of his brain, aren't we? This is from the side because he's got his head turned. Y'all see that? Now, what has happened for him is that they've done a mid-sagittal section. Mid-sagittal meant what? This will be on your first lab quiz. What is mid-sagittal? A dissection where they separated the right and left halves. And so now we're looking at this, right? So now that gives us perspective a little bit to be able to come down here and look at this. The only difference is the head's turned this way instead of the other way. Okay, so that's just giving you perspective there. So what we're seeing right here is that this is the medulla. This was the what? Very, very good. Midbrain, thalamus, hypothalamus, and pituitary. Here, y'all had to label those structures in the nervous system when we looked at the brain, didn't we? So we did this. Okay, so we all did that, right? So we did this. This is the frontal lobe. So just to give you perspective here, and you've got them highlighted in these different areas too. So definitely take a picture, I think, or take a look at these cadavers because they are nice to be looking at when you're looking at the illustrations as well. And it's a nice way for you to actually study this. You know, we can look at comparative species all day long. Rats, and we don't, by the way, y'all will dissect rats. And here, after we get through enough of the organ systems, we're going to spend a time in the lab where we're dissecting rats and isolating their organ systems out. Like you'll remove trachea, lung, and heart as one, and you'll remove some of the GI tract, and you'll do some isolation of these organs in a rat. But it's nice to look at rats and cats and fetal pigs and whatever, but really the best way to learn human anatomy and physiology is with what? Is with humans. It really is, because we know even then it's kind of tough, because are even two humans exactly right? No. But we can learn what are considered to be kind of norms. So I do remember that we had talked about this idea that the hypothalamus is kind of rolling and rocking the world, isn't it? Y'all remember learning that? And it is ruling and rocking your world. You could actually, no, that's not the way you answer that on my quizzes. I will have people who say that and I'll laugh and I'll think, God, I hope they know what I meant. But here's what I want you to know. This is the area that information is coming into that is going to control most of your major other endocrine glands and organs, either directly or indirectly. This is the area that if you've got a temperature that you are actually vacillating around. Is that right? Could I take you all's temperature and measure it right now? Could I do that? I mean, we could. Can you take your temperature and measure it? Would it be the same in 10 minutes from now? Probably not. Would it be the same exactly as what it was when you woke up this morning? Probably not. So you're saying that your temperature is vacillating around set points. What's controlling the set points and the parameters that are normal, high, normal, low? The nervous system. It's the hypothalamus that's setting. If you feel thirsty, guess where that came from? That drive came from.
If you feel lusty, is lusty a word? Lustful. If you feel lustful, guess where that came from? Hypothalamus. You thought it was somewhere else, did you? It did. So anyway, yeah. So this hypothalamus is really, it is ruling and rocking your world. It is where so many things we know are actually the center of where these stimuli are actually going to be regulated and are going to come from. Now, how it carries out most of its function is you'll see where the hypothalamus is lit up here, and there is this tiny little stalk of tissue. I'm not going to have you label it. It is called the infundibulum, but it is a little stalk. It's just like held by a thread. It's holding the pituitary gland. And this pituitary gland is absolutely encased in that sphenoid bone. Y'all remember the sphenoid? Yes. Encased in that sphenoid bone like a pearl. This hypothalamus, by sending hormones through this little tissue to the pituitary, is going to turn the pituitary on and off. And those hormones all have names. They all have names. And they're going to be the only hormones that we talk about that I'm actually not going to test you on their names. But their names are kind of intuitive. And you do have to remember that it is the hypothalamus turning on and off the pituitary. So there are going to be 8 hormones from the pituitary that get released from the pituitary. But would any of them get released without a signal from the hypothalamus? No. Would any of them be stopped being released without a signal from the hypothalamus to tell it to stop? No. So we do understand that. Okay, you've got to understand that. If I were to ask you which organ controls either directly or indirectly all of the other major endocrine glands, what would you say? Thank you. And don't forget that. And how does it do it? By sending hormones, individual hormones, that will either stimulate the pituitary to release a particular hormone or send a hormone to tell it to stop. Yes. So do make sure you kind of, you get that. Now, embryo, we don't really have a lot of time for embryology. Okay, so you've got tons of pictures. You should look at them, because are you going to need to label the hypothalamus and the pituitary? Could you do it now just from our talk? Hopefully you could, even looking at a lot of different pictures. Hopefully you would be able to do that. Now, really, Lord have mercy, I don't like this picture. All right, that's fine. That's fine. Can everybody see this picture in here? I got a better one, but anyway. So we see this little stalk of tissue, and we see this pituitary. Does it remind you of anything? Okay, I don't know if y'all know about fractals, but what fractals are is this idea that, structures just repeat themselves in nature, right? So we can often see repeated kind of structures. But anyway, so when we think about the little pituitary, we do get, it's a pea-sized, pea-shaped gland sitting like a little pearl in that sphenoid bone, totally encased and protected. And we've got really, actually, when we look at it up close, we've got a front and a back part of it. So an anterior and a posterior pituitary. I'm not going to have you label anterior, but I'm just not. I just want you to know it does. This is what it looks like. There are going to be 6 hormones coming from this front and a couple that come from the back. Are you going to need to know all 8? Yes. And what are you going to need to know about the 8? They don't get secreted and they don't get stopped without specific hormones from the hypothalamus. Thank you, because that's exactly right. And then what are you going to need to know about all 8 of these hormones? Their function, and where they're targeted. They're target specific, and then their function once it gets there. Aren't you? And then if you know that, then just intuitively, you're going to know why it got released. So, okay. So that's exactly right. Now, I think there's another picture I would like that's better, and I can do. Well, this is okay. It's not great, but okay, it's not bad. All right, look. All right. What did y'all say this gland is? It's pituitary. It is. And what I want you to know, we're going to start. We'll take a break in a minute. Is everybody okay? Everybody's good.
All right, so let's go ahead and start. Are y'all excited? You're about to get your first hormone. Okay. Okay, so here's your first hormone, and we're really starting with pituitary, even though we know that these hormones wouldn't get released unless another hormone from the hypothalamus had told it to release. And they're really like one that would target the thyroid gland. This would be thyroid releasing hormone. Just FYI, that's what it would be called. And then the pituitary release, it's thyroid stimulating hormone. Do you get what I'm saying? So their names are very kind of, again, I keep saying intuitive, but it really is kind of intuitive. But we just know, we're just going to know that they're all being released from there. Now we're going to start our study of the endocrine system. So let's go ahead and start with these 6 that are from the front part of the pituitary. Ready? These 6. Now they're going to be very special tissues in that tiny little pituitary gland that their sole function is to release this particular hormone. So let's start with the first one, prolactin. You will want to know how to spell it. Prolactin from the pituitary. So right now we know pituitary. Prolactin. Prolactin is going to target, and as you see, I'm a visual learner, so these kind of things help me, but it's going to target the mammary glands. So what do you think it's going to be the function once it gets there? To make milk for lactation. That's exactly right. So it's the pituitary that sends a signal in the form of a hormone called prolactin that will target mammary glands and women so that women will start to make milk. Right? So that's its function. So what would be the stimulus for it to be released? I mean, you don't have to write this down right now, but let's just see if we can think of a stimulus. That's very smart. So just because those of you breastfed know it doesn't take a baby sucking, does it? A baby can cry. You can actually think, is it feeding time? Then all of a sudden, it's like you have a letdown response, right? You don't even have to hear the baby cry. You can just actually just think about it. But what would prolactin levels have done when you did that? They would have spiked, and you were going to be making milk, right? So you're saying that a stimulus for the release of it will be a recent delivery or an imminent delivery? Is that what you're saying?
Yes.
And you're saying that the stimulus for the release of it would be like suckling? And maybe even just the crying once this can actually do, right? And you're all correct on that. That is a stimulus for the release of prolactin. There are some young girls at puberty that have an endocrine disorder where at puberty, just stimulation of the areola and nipples, like even in a shower, or at least that's what they tell you. They don't tell you that other stuff's happening. But you know, they are dating, so it might be that some other stuff's happening. Stimulation of the nipple. And guess what they'll start producing? Milk. This can freak them out, right? Because there hadn't been a pregnancy. Now that's an abnormal situation. That would be abnormal, wouldn't it? You know, but it can happen, and you'll see that people will have this hypersecretion of prolactin. Because do we want a hypersecretion of prolactin? Do we want to be ladies? Do we want to be making milk when we don't have a baby to feed? No. So you know, but there are these abnormal. Are there abnormal situations where women do have a baby? They just have it, and the milk's not coming in. Yes. What's that? What do you think is most likely the problem? Hyposecretion of what hormone? That's exactly right. So good. Do we know prolactin? Do we own it? Do we know?
Does that have something wrong with the hypothalamus or the pituitary?
So, thank you. Sorry. Thank you, Nicole. No, thank you, Nicole, because we get that it might be a prolactin if somebody's not making milk, a hypersecretion of prolactin. But does that mean it's necessarily the pituitary? No, because we understand that the pituitary was getting its signals from where? So it could be a problem with the hypothalamus, couldn't it? Yes. So we don't know. It would have to be figured out. You're right. Understanding that the hypothalamus is really the wizard of this added an entire another level of understanding the endocrine system. It really did. So So great. I had I love this girl. I don't know about, but I really do love this girl. She is in the second semester of the nursing program right now, and she was not that much yet. I had her in my class in the summer before she was starting the nursing program, and it was the summer that she was about to start in August, right? So she was finishing up Ampy 2, and on August 1, she had brain surgery, and it was so she had planned. Oh, it's on August 1, and they were going to try to go through her nose, but she had a really tiny nose, so they were really worried that they might not be able to do it that way and would have to go a different route. But so the brain surgery was because of a tumor of the pituitary, and it was causing hypersecretion of prolactin. So that was one of her main signs and symptoms that made her know she had a pituitary tumor. And guess what? It did get to go through her tiny little beautiful nose, and it worked. Yeah. So just luckily or hopefully that will be all that you know having other issues that's saying. So anyway, so prolactin, ready for number 2? Yes. Thyroid stimulating hormone. Should you all know abbreviations and exactly how to spell them? Right. So thyroid stimulating hormone. Where's it from? Pituitary. Where do you think it targets? Because it's in its name. We love it when it's in its name, don't we? We love it when it's in its name. It's targeting the thyroid. And here's a little picture of this butterfly-shaped gland that's right here in the base of the throat, thyroid gland. And so we know it's going to do something when it gets there, isn't it? It's going to do what? It's going to stimulate it. And listen, don't make this harder than it is, because that's exactly what it's going to do. Now, so far, I haven't told you what the thyroid does, but we will get to the thyroid because it is a major endocrine organ. So, but you will take my word for it right now that the thyroid gland controls metabolism. So, thyroid stimulating hormone stimulates the thyroid to release its hormones that raise metabolism. So put a little up arrow. Do you think you need to know if something raises or lowers something? So it raises metabolism by stimulating the thyroid to secrete its hormone. So what would be the stimulus for the release of it? Your cells are sending a signal to the hypothalamus that metabolism is doing what? Slow. Metabolism slow. So what should you see starting to go up? TSH should go up, and hopefully your thyroid hormones will go up, and then your metabolism will go up, because we understand what kind of feedback do we mostly say in. Good enough? Are you good? I need to step back and tell you something about prolactin. What about men? Do they not have prolactin? They do?
They have memory glands.
So men actually do have prolactin, and what we know prolactin does in men is actually increases the function of something called LH, which we haven't gotten to yet, luteinizing hormone. But do go back to your little prolactin and say, in women, you know exactly what it does. It causes milk to be made, right? And in men, it's going to increase the sensitivity to LH. And we're going to talk about LH in a second. Ready? Then we'll take a break.
Can you go back over the thyroid one more time, please?
Yeah, so the thyroid gland, TSH targets the thyroid gland to turn its hormones on, and it raises, that will raise metabolism. Okay? Are we good with that? So, if someone has low metabolism, what is metabolism, by the way?
Chemical reactions.
So it's a sum of all the chemical reactions occurring in all your cells at any given time. So really, what it really is when you think about metabolism is the rate of work your body's doing. Does your body always need to be up here? No. So sometimes your metabolism's getting kind of up. Your body, the cells kind of slow down, and sometimes they speed up. Sometimes they slow down. So metabolism is just the rate of the work that your cells are doing in any given time. That's exactly right. And so if somebody has a low metabolism, you're saying it's the thyroid that's the problem? It might be, but it might be the
pituitary or hypothalamus.
yes. So you don't know, do you? But there's some tests you can do to figure out. Okay. So great. So good. So we're beginning to think. But this is a little bit interwoven. Maybe, we got to be thinking about how these are connected, right? And we hear about a hyposecretion or hyposecretion. And we're going to be thinking about these things. Let's do the gonads, and then we're going to take a little break. But the gonads, what are gonads? Yeah, so they're the primary sex organs, aren't they? So in women, they are. And in men, gonads are. I had a student one time say, ovaries aren't gonads. They're like this. And I think the student used a word I hadn't heard in a long time for the testes, but anyway. I'm not naive, I know exactly what it meant. So anyway, but gonads in women are ovaries, and gonads in men are the testes. They're the primary sex organs. And so so what we know is, and this is just a word you might sometimes come across, and you won't know where you'll know. If you hear about a gonadotropin or a tropic drug, hormone or whatever, it just means it travels to there. So wherever you hear, that means it's traveling there. So gonadotropins travel to the gonads. That's exactly right. So when you hear about LH and FSH, let's first know what they stand for. FSH stands for follicle stimulating hormone. And I want to talk about that one first, if you'll allow me to. Follicle stimulating hormone, FSH. It is a gonadotropin because we know it's actually released from where?
Pituitary.
Pituitary, way up here. Way up here. But where is it going to target?
The ovaries.
The ovaries if you're female, and it's going to target the testes if you're a male. It's going to travel to the gonads. Is that right? So these are considered to be gonadotropins. So FSH, follicle stimulating hormone. You all are going to have charts in your book that give you some, I think, some whatever. But let me tell you what they do. What it does. FSH targets ovaries so that a follicle will be stimulated, follicle stimulating hormone, for an egg to mature within inside that follicle. So, do y'all know that all female little babies are born with all of the primordial eggs that they will ever have? They're inside these little tiny follicles that are called little follicles. A female baby, next little female baby you hold, think about her little ovaries are filled with several hundred thousands of these little primordial follicles. At puberty, one will get targeted. That follicle will get targeted and stimulated, so the egg inside will mature. So in women, the follicle stimulating hormone will target a follicle for the maturation of an egg. In men, follicle stimulating hormone will target some of those same types of cells in testes that will cause what to mature? Sperm. So follicle stimulating hormone is why we get eggs that are mature and sperm that are mature. I think that's a pretty important hormone, don't you? All right, now let me talk about luteinizing hormone. First, we'll talk about women. So where is the egg maturing? Where is it maturing? Because the FSH is targeted at the what? So there's this follicle, and inside this follicle, which is a fluid-filled sac. What's the word we use for fluid-filled sac? We use cyst for fluid-filled sac. This follicle looks like a fluid-filled sac, but there's an egg inside maturing. If that follicle didn't release that egg, could sperm ever get to it? So the follicle's going to have to do what? Rupture. It's going to have to rupture. I had had a rough weekend. Can I tell you all that? Hey, God, I got 2 people. I got 2 people. So many people here. I don't know why I keep seeing. Okay. Anyway, so that follicle is going to have to rupture, and what's going to cause it to rupture is LH. So you know what you all call the rupturing of a follicle? No, you don't call it that.
Ovulation.
Ovulation. You all call that ovulation. How many of you feel ovulation when it happens? Some, like I had a best friend who would feel like, she said it felt like somebody pinched her inside, like just a quick pinch. And she would say, like, I never forget the first time she said, oh, I just ovulated. Like, what? So I've never felt that. Does anybody in here feel that? Okay. So some women do feel that. And it's actually by the names. But anyway, I forget what the name is. Y'all look that up. But anyway, that's ovulation. The follicle ruptures, because it is a fluid filled sac. It ruptures, and the egg is released. So now there's a chance that if there's sperm in the neighborhood, what might happen? Well, it's a long time until baby can happen. But what? Fertilization can happen. Or maybe the sperm will join with that egg, and that's called, that event is called fertilization. Where does fertilization usually occur? It usually occurs right outside that ovary, right at the mouth. You've got this ovary, and then you've got this tube that's right next to it, and it's got, the tube has these little finger-like things that are doing this, encouraging the egg to come into the fallopian tube. And sometimes fertilization happens right outside that, or right at the mouth of that fallopian tube. So fertilization, if sperm is there, can happen right there, and then it's got to travel all the way down, right? Okay. The fallopian tube to the. How long does it take it to get from there? A fertilized egg. And by the way, once ovulation occurs, you only have about an hour. And if fertilization doesn't happen, that egg is going to die. So if it happens, and how long does it take for that newly developing group of cells to get to the uterus? 6 days. About 6 days. It takes about 6 days for that to actually happen. So cool so far, right? But if it doesn't, so if fertilization happens and the cells start to divide, start with one cell. What's that first cell called? A zygote. It's called a zygote. And then one cell that's a zygote becomes 2. Then the 2 split, you got 4. Then the 4, you get what I mean. And now you've got this group of cells that call a blastocyst. Blast means what? Early. And a cyst means what? A fluid-filled kind of little sac, right? So the first 2 weeks, this group of newly divided cells is called a blastocyst. If while it's traveling the fallopian tube, it gets stuck, but it's continuing to divide for a bit. That would have been death back in the Dark Ages. That would have meant death for that woman. Now it's an emergency surgery procedure, and they'll have to remove the fallopian tube and remove that blastocyst. They'll have to do that. That is a ectopic pregnancy. That's what people mean when they say ectopic pregnancy. Okay, but what does LH do in men? Because it's a gonadotropin, it's traveling to the male's testes. We know that FSH does what in men? Mature sperm. But what does LH do? Testosterone. So this is going to target special cells in the testes to bump testosterone levels up. And truly, these hormones don't stand alone, guys. So testosterone levels are needed for sperm production too, but it really starts with the FSH and the LH, and then testosterone levels go up too. So when we think about puberty in women, we do understand that these ovaries of women, the follicles, once they're stimulated, once FSH is released, these follicles are going to start secreting their own hormones. What hormone might you guess in women is the hormone that's going to start to go up? And estrogen is right. And what? Progesterone. So estrogen and progesterone. And so at puberty, what are little girls starting to, are they starting to look different? What do they look like different? Well, breast formation, fat in areas that you associate with the, female, right? So we think about, that's estrogen and progesterone have far-reaching effects, don't they? And then in males, what happens at puberty in males with that testosterone level going up? Does testosterone just target one side in males, or do you get a lot of, does estrogen just target one side? We already talked about estrogen being a big player in bone health, didn't we? And how bone builds. So now we know that in testosterone, what are boys at puberty? Bless their hearts. Their boys. You're having men in here, so we can really do a lot of things. We can have all kinds of sessions outside the session. No, I'm just kidding. What? So beard, axillary, pubic hair, same thing with the estrogen. Women doing this axillary and pubic hair. Larynx, what are they? Their voices deepen. They get the Adam's apple. Muscle mass. Do men have higher muscle mass than women? Yes, and testosterone has widespread effects, doesn't it? There's some things that we know target specifically, but there's some hormones that we know have widespread effects. This is all. Let's take about a 10-minute break and we'll come on back. Madeline, I know you know Canvas because of Micro, right? So you're good with the Canvas thing. Okay, I'm going to pause the recording. So we're back. We're still on the same slide.
Was LH number 4? Yes. What's LH stand for again?
Luteinizing hormone. Luteinizing hormone. And by the way, it's going to be in the PowerPoints. And y'all have access to these PowerPoints, don't you? But certainly in your textbook too. So,
April 17, 634.
There's a table of those.
Okay, here we are. We're back. So this next one, so we're still talking about this little tiny gland, the pituitary, and just the front part of it. And we've already seen, do these seem like significantly important secretions to you? I mean, yes, they do, and we're not even finished with the front part of the pituitary. So let's look at ACTH, and it stands for, you'll want to call it ACTH for now, but you do want to know what they stand for. It stands for adrenocorticotropic hormone. Adrenocorticotropic hormone. So we're going to call it ACTH, right? Now, tropic, what did I tell you meant? Travels to. So adrenal suggests that it's probably traveling to the adrenal glands. Let's break adrenal down. Renal means what? Kidney. Ad means what? Always. Superior to. So where are these glands sitting, do you think?
Above the kidneys.
Above the kidneys. They're sitting like little hats on top of the kidneys. These adrenal glands. They're nice, they're called that because they're telling you exactly where they are. And here's a hormone that travels to them. So again, adrenocorticotropic hormone. The cortical part is referring to the cortex. When y'all hear the terms, and it's not just with the adrenal glands, you'll hear the terms cortex and medulla when you're referring to quite a few different organs. They will always kind of mean the same thing. Cortex means the outer, and medulla means the what? Inner, the middle. That's what they mean. So this hormone, its name sounded so awful, didn't it? Adrenocorticotropic hormone. Again, no such thing as big words. This just means that it's a hormone that's traveling to the cortex of the adrenal glands. Now, do you think it's just traveling there for it's, because it's a fun place to go? Or do you think it's going to target the tissues there to do something? So I think it's going to have a function once it gets there, don't you? And I want you to, for right now, because see, we're going to talk about these adrenal glands. We're going to talk about the cortex, and we're going to talk about the medulla of the adrenal glands. But for right now, what I want you to know is that this controls that adrenal cortex. And then maybe in parentheses, you would understand that the hormones the adrenal glands are going to produce are going to control things like electrolyte balance, glucose, and in parentheses, go ahead and put electrolyte balance, glucose homeostasis, tissue repair. Do they sound like important things the adrenal glands are doing?
Yes.
And so now you got that in parentheses, and you got a teaser for when we get to the what gland? The adrenal glands. Don't you? You got a teaser. Just like you had a teaser over here about the thyroid. What did I tell you the thyroid is going to essentially control? Metabolism. All right. Now, you good with that? Now, I want to talk to you about, and this is not usually abbreviated GH, it's usually abbreviated HGH. This is how you usually see this abbreviation. And it stands for human growth hormone. Human growth hormone. Now, I want you to know human growth hormone, where is it released from? Pituitary. It's going to target the liver. And the liver is going to release products that are going to control, guess what? Growth. Sometimes y'all make things harder than they need to be. So it's actually going to the liver is going to release some products that are going to play with this, and it's going to help with growth. So obviously it would be important during what years? Yeah, during the growth years. But so then all of y'all have reached full growth potential, so y'all think you don't have any growth hormone anymore? No, because we know it has more functions than just growth, though certainly it would be important for growth. Certainly. But throughout our lives, we release human growth hormone because we know it has more functions. It actually is going to help with tissue repair. Don't we get injured? Don't we need tissue repair? We do. We need tissue repair. It is also going to help with like protein synthesis. What did I tell you? Your cells are essentially what kind of little factories? They're little protein factories. Because proteins, there's one category of the thousands of different kinds of proteins called catalysts. What does a catalyst do? Speeds reaction. So do our cells need to be keeping our proteins at a certain level so that everything else can happen? Yes. So human growth hormone is important throughout your life. Certainly the levels of it start to decline in early adulthood, actually. And they will start to decline because you won't need as much of it. But so what do you think could be a sign of hyposecretion of human growth hormone in children? They're not developing. It could be what's called pituitary hypopituitaryism, where they become, it's called pituitary dwarf. Right? So that makes sense, doesn't it? Does that make sense? Okay, and then if we had a hyposecretion in adulthood, we could also see things like maybe problems with tissue repair, maybe problems with cells just repairing themselves or whatnot, or metabolism. Sometimes that is a decreased human growth hormone factor. But what could happen if you had a hypersecretion of human growth hormone in childhood? Tall and fast, is that a disorder? Yes. Could be if they get over a certain size, because what is that called? Well, Marfan syndrome is going to be has a different issue. It's going to be a disorder of particular fiber. But actually, you can have gigantism. You know, people's cardiovascular system, people's cardiovascular system and organ systems are work perfectly at a certain place. But if you get too much over that, joints, cardiovascular disease, so gigantism really is a disorder. And I don't know the actual number and height that you're considered a giant. Does anybody? I think it kind of has changed, so I never could have committed anything to whatever. But I think it's like 6'10", 6'11". You know, so because then you start seeing some issues that people are having. But in childhood, so gigantism. But can you have a hypersecretion of growth hormone in adulthood? You know, you can. Because let me tell you if this is, and it's called acromegaly, A-C-R-O-M-E-G-A-L-Y, acromegaly. So it's going to be in your notes in a little while, but it's called acromegaly. I'm getting a little ahead of myself giving you disorders when I should just be talking about normal. But I think sometimes when we're learning the normal, when we talk about the disorders right here, it kind of makes sense that that would be the problem. And sometimes people can remember them better, I think, if we talk about them during or right after we introduce them. So acromegaly means that for some reason it's usually a tumor of what gland? Causing hypersecretion of human growth hormone in adulthood. So this person is not going to get any taller. Why not? The epiphyseal plates have closed. The epiphyseal plates are the growth plates of long bones, and they've closed. So that person's not going to get any taller. But the irregular bones, like the mandible and the frontal bone and the irregular bones in the hands, they will continue to grow. So what you will see is this, and it's usually pretty apparent when somebody has acromegaly, which is a hypersecretion of human growth hormone that starts in adulthood. I had a student one time that after this lecture, and I see her occasionally, but she came up to me and she said, "I have that, don't I?" And I was like, "Yeah." I mean, I would have thought she would know what she had, but she didn't know it until that lecture. And the only thing I could think of is like, "Do you go for physicals?" Because it was really apparent. I thought she had it before that. She went after that. What'd you say? Was she young? Yeah,
how old
very
was
young. So she was, I think she was in her like late 20s when it happened.
How do they know that, excuse me, that the hypo is a pituitary dwarfism and not an effect over the liver or the hypo?
Well, and they have to rule that. They have to see that. They have to make sure that it's not somatomutants that the liver is not producing or whatever. But it does seem to be typically the growth hormone that is the problem, because when they look, they'll typically see not just a hypersecretion of this, but they'll sometimes see hypersecretions of the rest of them too. Now, I hadn't brought this up yet, but maybe this is a good time to introduce this. I usually ask the class, I want y'all to really think about it without saying anything out loud. So if somebody told you today that you just pick something out of a hat, a disease out of a hat, and you're going to have to have it, that would be mean. But if somebody said you had to pick something, a hypersecretion of an endocrine hormone or hypo, which would you choose? Would it be worse to have too little or too much? Now, this is such a silly question to ask, but are you sitting there thinking about it? Because, you know. Okay, so what would you want, Aaron? You say hypo?
I just think of like cooking, like you can always add to it, but you can't take it away.
Actually, that's not a bad analogy at all. So maybe y'all will remember this. Because the fact is, if you have a hypersecretion, it's usually going to be because of, it can be because of a tumor or whatnot. But then you would think that you want to remove that, right? But when you remove that, then what are you going to have? A hyposecretion, and then you're going to have to supplement, right? Here's the good news. This is really good news. This is really, really good news. You can, most of these hormones can be synthetically made now, and people can get them. Now, for each individual, you have to, it may take you a little while to get them at their right level, their right dose. It's like you said, you know, you can add slowly until you can get them where it looks like your signs and symptoms are abating and they're feeling good, or, you know, you're doing blood levels and it's looking like they're pretty good. And it might take a lifelong management thing, but you'll get them where you need to be, where they need to be, right? So I think I'm with Aaron, you know, so maybe a hyposecretion would be best, because a hyper would mean that you're probably gonna have to take care of something that's gonna then put you in hypo, and then they're gonna have to replace it. And also, when something's there in a huge amount, is it really, can you get rid of it immediately, or does it take the body a while to process and get rid of? Yeah, it takes a while. So, so anyway, just something to think about.
Is there a chance that with that going from hyper to hypo, is there a chance that the body could at all start making its own again?
Oh yeah, absolutely. It would depend on which organ this was happening to. Yeah, it could. And then there's also so many new things going on right now as far as stem cell replacements and whatnot. And I really just think in the next 10 years, there's just going to be a revolution with this molecular cellular treatments options, right? That are going to really help people. You know, we tend to hear all the bad news that's out there floating over our heads every day because we can't get away from the bad stuff. You know, we should all just put our phones away. But what we really realize, it's never been a better time to be human on this planet, to be alive. There's the human condition has really improved so much in the last 50 years. So, okay, now I sound like Pollyanna, but that really is the case. All right, so that's the front part of this. That's the front part of this little pituitary organ. But I want you to know there's two hormones that come from the back part. They're not made in the pituitary, but they are stored and released from the pituitary. These two other hormones. How many hormones do y'all have now? 6. And now you're about to add 2 more. You ready? The first one I want to talk about is called antidiuretic hormone. Antidiuretic hormone, ADH. Now, guys, when y'all hear the term diuretic, what do you think of? Do you think of giving somebody who had fluid buildup, an excess of fluid? Is that what you said? And what is a diuretic going to get you to do? If you take a diuretic, what is that patient going to be doing? Peeing a lot. Because what is urine? What is urine? What is urine? It's urine. So, but I mean, what is urine? It is filtered blood plasma. That's what urine is. It's filtered blood plasma. Blood plasma is the liquid part of your blood. When somebody gives, how many of you given a pint of blood before? When y'all give a unit, but a unit of blood, that's whole blood, right? But if we spun that blood down where the cells were on the bottom, the extracellular fluid, more than half, more than 50% of whole blood is liquid. That liquid's called plasma. That plasma is mostly water. So as your whole blood is moving through your kidneys, the plasma is being filtered. And plasma is mostly what? Water. Urine is filtered blood plasma. It is mostly water. And then hopefully you've also filtered out some waste products from just normal metabolism. Your house, people get so freaked out about urine, but urine is a sterile body fluid. It's a sterile body fluid. It only becomes a little bit contaminated when it exits the body at the urethral orifice. The opening of the urethra is colonized with normal bacteria. And so that's the only place until then, it should be sterile. It should be. Now, sometimes it's not, and we call that a what? A UTI, urinary tract infection. But in normal situations, it's a sterile body fluid. It is filtered blood plasma. You are urinating predominantly at the rate you're urinating to control your blood volume. I want everybody to internalize that for a second. You are making urine at the rate you make urine to control your blood volume. Because your blood volume is in a closed system of vessels. And if the volume's going up, what's happening to the pressure inside the vessels? It's going up. And if the blood volume's going down, what's happening to the pressure inside your vessels? It's going down. So the more urine you're making, what's happening to your blood volume? Going down. So what's happening to your blood pressure? Going down. So somebody who is hypertensive, what does hypertension mean? High blood pressure, the first thing you give them is a what? A diuretic. Because it will make them pee more. It will make their blood volume go down quicker, and it will decrease their what? Blood pressure. So that's what a diuretic does. So what does an anti-diuretic do? It does the opposite. So let me tell you what ADH targets. It targets the kidneys. That makes sense, doesn't it? It targets the kidneys, and it's going to cause the kidneys to conserve water. Conserve water. So really, you could tell me that that's its function, but I would hope you would know that that's doing what to your blood pressure? It raises blood pressure. ADH is a natural hormone that you release from the posterior pituitary to target your kidneys to raise your blood pressure. Get over the fact that something raising your blood pressure is bad. It is not. You're going to see about 3 or 4 hormones that's their sole function is to do what? Raise blood pressure. Because is there a situation where low blood pressure can kill you? Yeah, it is. What's it called?
Yeah.
Well, dehydration will lead to that, but what's it called? Shock. Write down that medical shock is dangerously low blood pressure. Dangerously low blood pressure. So you have these built-in mechanisms that when your blood pressure starts to get low, this is the first one you're being introduced to. But what do you know will probably start to go high? ADH. And what should that start to do to your blood pressure? Help to be bringing it back up. But it won't be standing alone doing that. We're going to find out about 3 more hormones, 3 or 4, that are going to bring, that are going to work with it to keep your blood pressure up. If somebody's blood pressure is dropping too quickly, your body's going to try to respond by secreting these things to bring it up. So let me say this to you right now. If you're only urinating at a rate that you urinate to control your blood volume, when people think about urine as a waste product, most of the waste is water because you're trying to control it. It's hard to think about water as being a waste product, but it kind of becomes one because it's the major way we control blood volume. Y'all knew that was coming.
Urinating and blood pressure.
Oh, so, okay. So here you go. How much does a normal person, like a normal adult, and normal adults are considered to be 150 pounds. 150 pound average is a normal adult male female size. 150 pounds. How much do they, on a normal day, they're not in the Sahara, it's just a normal day. Not too cold, not too hot, whatever. How much do they urinate a day? What's a normal amount of urine production a day? Does anybody know? No, I meant actual amount in mLs or cc's. Same thing. mLs.
I don't know.
So it's about 1,500 to 2,500. So it's about 1.5 liters, 1.5 liters to 2 liters a day. So if y'all think about that amount, you know what a liter looks like, right? Y'all know what a liter. So about 1.5 to 2 liters a day. Did you know you pee that much? Okay, well, whatever. So that's a normal amount. ADH is a major player in controlling that. Someone who stops producing ADH suddenly, and usually the onset of this is sudden, when somebody stops taking so much for granted. You've been taking for granted your ADH. You really have. If somebody stops producing ADH suddenly, they will start producing 10 liters of urine a day. Can you survive that? Could you survive that very long if somebody wasn't pumping back in fluids? Could you survive it? You couldn't? You couldn't? Do you know what that disease is called? Huh? Does anybody know what that disease is called? I know some people have read ahead. What's that disease? Does anybody read ahead? Y'all want it to all be a surprise? Okay. It's called diabetes insipidus. Insipidus. Diabetes insipidus. I want you to know the word diabetes. When y'all hear the word diabetes, you're usually thinking about blood glucose levels, aren't you? Would I be right if I said that y'all, if you heard diabetes, you would think of blood glucose levels? That's not what that word means at all. It means an excess urine output. Diabetes, you're peeing a lot. That's what it does. Now, in diabetes mellitus, which there are many forms of diabetes mellitus, but in diabetes mellitus, is it about glucose? Yes. But in diabetes insipidus, it's not about glucose at all. What is it about? It's about not making what? You're hyposecreting ADH. And now you're making too much urine. Could you live without replacing that ADH? No, because you can't lose that much volume a day. You would be hypovolemic in a quick hurry, which would take you into medical shock. Your heart would get a signal to just stop.
How long would you survive with this?
Not long without treatment. You know what the good news is? You can do a daily spray of ADH. It's just a daily nasal spray of ADH. So please know that this disease is called diabetes insipidus. Diabetes just simply means you're making a lot of urine. Y'all probably knew that anyway, because what do y'all know is one of the first signs that somebody might have diabetes mellitus? They're urinating a lot. They're urinating a lot. That's going to be one of your first. Did everybody know that? Everybody knows that that's one of the first signs. It's for a completely different reason that you're urinating a lot, and we're going to find out what it is in this chapter, actually, why diabetes mellitus, those forms of it, causes people to have an excess of urine, which is called polyuria. Poly means what? Always. It means what? A lot. So polyuria. Uria meaning a lot of urine. So anyway, but it's for a completely different reason. So if I were to ask you all what is the etiology, which is the cause, the study of the cause of diabetes insipidus, you would say that's not the cause. That's a sign of it. What's the cause of it? Please, when I ask y'all questions, let's always remember this. Be reading to see what is the question asking. What is it? What would be the answer?
Decrease ADH.
A hyposecretion of ADH. ADH is from where?
Pituitary.
The pituitary. It's from the pituitary. Y'all feel good about ADH? Where's the target?
The kidneys.
Targets the kidneys, right? Targets the kidneys. What's it going to cause? What's its function going to be? Raise blood pressure. Which y'all know it does that by conserving water. You good? It just makes such good sense to me. Does it to you? Yes. Okay. All right. Now, the last one from the pituitary gland, the last one is called oxytocin. Oxytocin. Oxytocin is going to, oxytocin. Yeah, I don't even want to know this because y'all be reading it behind me. Okay, so oxytocin. We make a man-made version of oxytocin, a synthetic man-made version of oxytocin called pitocin. Has anybody ever heard of pitocin? Yes. What do you know pitocin does? You might want to write some notes just so you'll remember. Jumpstarts labor. Jumpstarts labor. Supposed to.
Also give you stronger contraction.
Yeah, I was just thinking how to jumpstart that. It's like, God, it just needs to be more powerful. So guys, what this synthetic version of oxytocin does is targets the muscle of the uterus. Your uterus is a muscular sac that is just perfectly designed at contracting and spitting out this fetus, right? It's because it takes the contraction. If somebody thinks they can just push a baby out, that would be impossible. The labor part of delivery is true labor because you are pushing, and it's the hardest work you'll ever do. I don't know what kind of work you've done, but it's the hardest work you'll ever do. But you couldn't do it on your own. You have this amazing organ called the uterus that is a muscular, really impressive organ that gets targeted by oxytocin, oxytocin to contract. And some of you have children, I know, and you all know that that kind of contraction is above and beyond anything you've ever felt, right? A Charlie horse doesn't compare to this, right? So, I mean, this is a contraction, right? It was an amazing organ. So oxytocin, one of its functions is to target the myometrium, myo meaning muscle part of that uterus. It targets that muscle to contract. And that's what's really helping to expel the fetus. All right, so we know it does that, don't we? Guys, how many of you breastfed? How many of you breastfed? How many of you have never seen somebody breastfeed? So everybody in here seen somebody breastfeed?
Before I breastfed, no.
Yeah, but you breastfed, so you know what it's like. But has anybody never seen breastfeeding? Okay, so everybody knows what I'm talking about when I say this. So you guys, you can make prolactin to make the milk, and the milk will eventually engorge the breast. The breast can get really hard if it's very much engorged with milk, and there can be some leaking of it because it's so engorged. But you know, babies have this amazing thing that they're born able to do. They have some amazing things that they're born. They can grasp and they can suck. But there's no baby ever been born that is strong enough sucking to suck out the milk. They can suck, and that's wonderful, but they can't suck enough to suck the milk out. Oxytocin targets the mammary tissue and causes contractions of the breast. Those contractions, those muscular contractions, eject milk. Any of y'all that have ever breastfed or understand breastfeeding know that while you are feeding a baby on one side, you're almost gagging them. Because as soon as the let down response happens, milk is hitting them in the back of the palate. And they're just doing everything they can do to keep up with what? Swallowing it, right? And on the other breast, what is happening? It's doing more than leaking. It's pouring, right? So it's pouring. You know, in pictures, it looks so beautiful to be breastfeeding. But if you have something over here, you're going to be a wet mess, right? So, because that's natural. So you make the milk with prolactin, but it's ejected because of what? Oxytocin. So oxytocin causes the uterus to contract to expel a fetus. It also causes the letdown response when you're lactating, the letdown response. And at the same time, it's continuing to, while you're breastfeeding for however many weeks or months you might breastfeed, is it also getting that uterus back into shape? It is. So this is another reason that they sometimes strongly encourage people to breastfeed, not just for the health of the baby, but also for getting that uterus back as quickly as possible. That makes sense? All right, so what else does it do? Does anybody know what else oxytocin does?
Isn't it like they said when you're breastfeeding that you want to release oxytocin for like bonding?
Well, when you're breastfeeding, you want to release it so that milk gets out, because that milk is engorging your breast, and you want it to get out so the baby, because the baby doesn't have enough suckling power to really suck it all out. So that's where you're doing that. But you are releasing it, and what we know is people who have these rhythmic releases of oxytocin, it absolutely plays a vital, important role in bonding, emotional bonding. Men produce oxytocin too. We produce higher amounts of oxytocin during sex. Skin-to-skin contact produces oxytocin. Rocking produces oxytocin. Hugging produces oxytocin. No clothes on hugging produces more. Do you get what I'm saying? Mm-hmm. It's all about producing oxytocin. So I don't know. I'm just saying it does, and so we understand this, and so that I love that they're now doing that what are they calling them? I forgot what they call it. Skin to skin path. And you know, they have like an hour to go. Like do it all day. I'm like, where do you have to go? Just keep it going. You know, it's really, they know it's an important thing. They have actually studied and know that people who, it's rare because we're animals and animals want life to continue. So once you ever have a child, it's never going to be about you again. It's always about that next generation. And so, like for life to exist, it has to be that way. So that's a natural thing that it becomes about that next situation. Oxytocin plays a huge role in that. But there's some people who don't secrete it and don't secrete very much. And so, if you've ever known somebody who you might think are just being callous with their children or whatever, I mean, they actually might have a physiological. I'm not calling it an excuse because their rational mind should pick up what their body's not doing. But I'm telling you, they really might not have the bond that you have. And then, you know, people who maybe go overboard, right? Who have like so much. When I say go overboard, I don't mean that necessarily in that way, but because I think I might have had too much, you know, because I was thinking, okay, I get why people kill people if they do something to their children. Like it's the first time in my whole life I could actually think that I could resort to violence because you're not coming near my child. You know what I mean? So, you know what I'm saying? It's like a weird kind of, not weird. I mean, that's really survival, isn't it? Survival of whatever, but you think of things that you thought that you wouldn't have thought of. Like I was such a hippie, you know, non-violence, whatever. And I'm thinking, don't get me wrong. You think you're gonna do what? So anyway, no, that's not.
Could a continuous release of oxytocin make you stay in like a positive feedback longer?
Well, for childbirth and whatever, and for my friend used to call these orgasms of the breast, the letdown response, which are kind of like many little orgasms of the breast. Anybody who's felt that letdown response, that is a positive feedback. That is a positive feedback. I've never really heard of anybody having orgasms forever, you know, or whatever. So I don't think you really get that. But I do think that, you know, some of those hormone changes after delivery, sometimes people don't have enough, and that may be causing other things for them that's causing anxiety, right? Because they kind of know that they're not having things that they thought would be a normal feeling. But then also having so much of it, it really can make you teary because you can think, oh my God, like you really do get that feeling of having. How many of you had that feeling? Like you thought, oh my God, I got to protect this thing now forever. I can't ever die because I'm going to be like protected. So, you know, you do get those feelings. It's whatever. Okay, does that answer that? I don't know. Did it? That is a positive feedback. When you're the letdown response is a positive feedback. The birth process is a positive feedback. You're in a positive feedback loop, but they know it breaks you. So anyway, oxytocin does that. What we know about, now listen, I kind of dislike the term autism because I think it's being used for way too many things, and y'all don't care what I think. But anyway, labels are being, because everybody's different. And right now we have this term called autism, that is the autism spectrum, right? That I just think, I don't know. But what I'm talking about right now is a very select little group that I think is when we first start using autism, this is the only people in this group, where they were young kids that stopped verbalizing. They were progressing normally, development until about 18, 24 months. But what we noticed, and this was years ago, what we noticed was they would stop their progress, verbalizing, stop wanting to be touched, so had no verbal communication, no eye contact, did not want to be held or touched, had the sensory thing. So a serious type of thing. Now we call, you know, autism spectrum, people who are getting PhDs and are very fun. You know, so I don't know where that has come from, but anyway, I'm talking about the kids who start exhibiting behaviors that are what I just said. They're going to learn that they're going to lose their communication, don't want to be touched, hypersensitivity, exactly. And you know what? For some of them has been affected. oxytocin. Being given oxytocin, within minutes, they're able to make eye contact, and they're crawling up on parents' laps that they wouldn't let a parent touch them. And the oxytocin has allowed that to happen. So for a very select few of people that are in that one little category, niche, if you will, that has been proven to be a successful treatment. How exciting is that?
So that's like everyday replacement.
Yes. Yeah.
How is that administered?
Because guys, have y'all ever wondered, like when you get a baby, and I don't mean your own, I mean any baby, what is your normal tendency to do with that baby? You're rocking, you're trying to get, and all of that does really release oxytocin. It does. If you ever wondered like that euphoric feeling after sex, you know, and I think women are more sensitive to their levels of that. And this is why, you know, we talk about like men don't want that after, you know, they fall asleep. You know, where women are like, okay, it's time to talk. But you get what I mean? So it's because we're driven by it. You know, I said our hormones really rock our world. They really do. They really do.
So if somebody has postpartum depression, do they not have the same levels as oxytocin?
Well, I haven't seen studies that have shown those levels, but they look at those. They do look at those. And there's different reasons. There's not just one reason that somebody has postpartum depression. It's really a significant number of women. Some of the last numbers I've looked at was the highest, like 20-25% of women experience some form of that. But I want you to realize, like, estrogen levels increase by 30 times normal. Your fluid volume increases by 30%. There's a lot going on when a woman delivers, and then shortly after delivering. And I mean, if you just think about the estrogen, progesterone, blood volume, all of those levels, let's take away oxytocin and all those things. That can really throw women who are maybe sensitive to it in the beginning, can really throw a lot of things off. Did anybody experience postpartum depression in here? And so how long did it last? And you got support? Thank you for sharing that, Jayla.
It lasted 6 months.
6 months? Horrible. And that's exactly what I hear. There was a pathologist that I worked for in Charlottesville, and I helped when he and his wife had their first baby, because she was actually put in a hospital for about 6 months. So it was just him and the baby. And so a lot of us, it sort of helped, you know, support during that time, because she had such a hard time. And her second baby, they do tell you that in second pregnancies you have a higher risk of having it, but it's not guaranteed that you would have it. And with their second baby, they didn't. She didn't have it at all. So, you know, because I think all of us that were close to them were thinking, is this going to happen again? Because it was devastating. It was devastating for her. You know, the baby Joe and the baby had a lot of support, but it's devastating for her. And she, you know, so for you, right?
Yeah, but I kind of refused help a lot.
You do what?
I tried to refuse help a lot because the fact that I had twins, I wanted to be
Her twins were precious.
because I didn't want to like receive help. I just wanted to do everything.
We women want to do everything. We need to stop that. Yeah, there's so much stuff going on, and they do, especially if there's part of a study, if you're in an area that, like Charlottesville was an area where people who were exhibiting that, they were trying to get them to let them do some testing and sort of figure out and what kind of levels they are. Because, you know, in science, we need data. We don't just need, you know, what somebody said. That, you know, so we need some data to support it. So I'm sure there are studies out there that have shown, but I haven't seen them recently. But they're looking at all those things. But there's so many things that can affect this. And we do know there's a hereditary component to it.
I worked with a patient that he was born, like, I read his chart because he was just mean before I got there.
It was what?
He was mean. Nobody wanted to work with him. And I had been at this prison for 8 years. And I read his chart to see why he was so mean and no one wanted to work with him. But his mother threw him in the dumpster shortly after birth, and he had like
A brain injury, traumatic brain injury.
yeah, on top of his head. So I, pretty much worked with his head and pretty much got.
How old is he?
He was born in 1970.
70?
So I pretty much, got his scalp well, and he's beginning to come around and talk and joke with me. But I was wondering when I was listening to you talk, was his mother was the oxytocin level in her?
Well, see, that's what we see. We have seen that. We've seen like men, and also like we are a species where we're not as much as some species. Some species, like the males, are truly caregivers, right? In our species, we're not as much, but we are tending to do that. But the men who show most of that have higher levels of oxytocin that show that real caregiving for children. Were ones that that just walk away. But some women can walk away, right? Some women can walk away, but it's a different thing to walk away than to do harm, right? To the baby.
Yeah.
So could
He gets a pill called oxytocin.
to help him relate to, yeah. So it'd be interesting if you could actually find the name of that drug, like bring us the actual name of that drug. I'd be interested in that. But yeah, so I'm not trying to stand up here and tell you all that people should use these as excuses. It's just that we are understanding that sometimes it's not just situational behavioral. Sometimes it truly is. I mean, these are physiological drives as well, right? So understanding that can sometimes help us to understand more about what might be driving people. And I think we're learning so much all the time. This oxytocin is exciting, especially for these little kids that are the early diagnosis of what I call the typical autism. These are kids that would have never been in school, never been able to read and write and whatever, but that they are then becoming able to do this. That's exciting. That's really exciting. And for this gentleman, and who knows what his mother had thought, it's just pretty amazing that y'all will hear and you will see like women who deliver and immediately want to harm their fetus, their neonates, and they know that it's a type of psychosis that can happen right after deliveries, but then they will be let go and with the child, and then they'll come back, and lo and behold, this has happened so many times in this area, lo and behold, then the child is not made it out of the first month because of harm, and you have to think, well, so when you had seen that in the hospital, what are they calling it now? They used to call it an Atlas warning. What are they calling it now when a patient has gotten out of control and so either self-harm? Is it still called Atlas? So anyway, you'll see that, and then a week later they get to go home with the child, and you think, whose fault was that? Is that really the mom's fault? I don't think so. Not when the people that were around that were healthy were trying to make decisions, didn't support the child, right? I don't know, because we all takes a community, doesn't it? I do think it takes a community. It's just really hard. I don't know. We kind of got sidetracked there, but oxytocin. We're finding out more and more things about oxytocin, and that wasn't long ago discovered. So that's kind of a new treatment, and just figuring out what the dosage is and kind of whatever that can maybe help that. I think about, can I just, do y'all mind if I should turn the recorder off? Do y'all mind if I just say one thing about the labeling, like the ADD, ADHD, and all the things? Those are labels, and everybody's different, and those are just labels, and don't necessarily need. That's not something that needs treatment necessarily. You know what I'm saying? Because we aren't supposed to be sitting like y'all.
That's so unnatural what y'all are doing right there to try to find out this information. I don't know what else we can do, but it's unnatural, and it's especially unnatural for little ones, little kids, K through 12 to be doing it. So to get a label to do all these things, it's too much. Yeah.
My brother was diagnosed with ADHD, and he was on medication for a long time. He eventually weaned himself off of it. My parents didn't even know, and like they would give him the medicine in the morning, but he would just put it right back in the bottle. He would never take it, and he was perfectly
And
fine.
he did it. Yeah. Well, so you know, I'm not saying people should not do treatment. I'm not wanting to tell you all that, but I do know that as a society, we're doing a lot of labeling, and sometimes it's not for the individual. It's for it's for some other reason. It's either for funding to the county schools, or it's to help a classroom, you know, sort of situation, or to whatever. And that should never be the stimulus. The stimulus should be what? The individual. And the labels don't help people. And they just really don't. So yeah. And chemotherapeutics, there's no such thing. Y'all know a chemotherapeutic just means a drug that's used to treat. So some people say, for cancer? No. That is one form of chemotherapy. But drugs to treat something, there's no such thing as a safe one. There's no such thing. There's going to be downsides for every single one. So, I mean, it really needs to be that whole process of choosing, of making that choice is a serious one, is a really serious one. And I don't know, I just think we label a lot of things now. And then maybe we saw me a lot more oxytocin. What do you think? So this is something that we do want to know that where it comes from. All right, so we know that the pituitary is actually could be in control, though, from where? The hypothalamus, and y'all won't forget that, will you? I'm not going to give you all so much that, though I might come back to the somatomedins, these insulin-like growth factors. Well, actually, let me mention it now. I told y'all the growth hormone, these are new sets of notes for me, so I'm trying to stick to them, but I'm so old school. The human growth hormone from the pituitary, I told you, targets the liver, didn't I? And I said, and then in conjunction with what the liver produces, it's going to have widespread effects for growth, regeneration, protein synthesis, all those things, which we know to be good things. But how the widespread effects happen is through this intermediary hormone, somatomedins, that act like insulin growth factors. So here's mostly what I want you to have in the back of your mind. I'm not going to ask you about this. Everybody throw some pencil down. But you will remember that human growth hormone, because it is doing all of that in the body, it is going to be a player in glucose homeostasis. Human growth hormone is a player in glucose homeostasis. Glucose is what? And it's a sugar that's needed for, mostly when we think about glucose, it's needed in our cells to make ATP, which is our cells' batteries, charging our batteries, isn't it? So every cell has to have glucose. Glucose homeostasis is vital, but it can't be too much, it can't be too little, because that's not going to really be compatible with life. And so we already knew that insulin and the pancreas, y'all knew that coming in here, plays a role in glucose homeostasis. What we know now is that actually some other things do too. So growth hormones, and I'm going to mention something else in just a minute, but anyway, but growth hormone is a player in insulin, is a player in glucose homeostasis. So I really do kind of want you all to know that. All right, another thing I wanted you to think about is, we said cells are pretty much protein factories. And so we do continue to need this human growth hormone. But I wanted you to know this. How many of you read labels on food things?
I'm such a hypocrite standing up here. I changed clothes 3 times this morning because nothing fits. So, but anyway, so please don't listen. I'm 60, so don't listen to, I'm not trying to preach at anybody because I'm the biggest hypocrite, but I do understand the chemistry. Here's what we need: a human growth hormone. And there's some things behaviorally we can do to boost our human growth hormone levels. When we eat high carb diets, how many of you eat high carb diets? How many of you eat high meals that I have? Like how many of you like 1 serving of spaghetti? Like really? The size of the sofa? Are you kidding me? So anyway, that'd be 1 serving the first time. And in 10 minutes, I've got another serving. So, but anyway, do y'all know what I'm saying? How many of you know you overeat carbs? When you overeat carbs, you are suppressing your human growth hormone. How many of you know you don't get enough sleep? You are suppressing the human growth hormone things, which is suppressing how your cells function. How many of you probably know that you don't get that, whatever they're recommending, you change it every week? 30 to 40 minutes of, rapid walking. You don't have to be lifting weights, but how many of you don't get that a day, every day? So you're kind of putting this in. So we need to be sleeping regular patterns. We need to be not eating proteins with each meal and not very many carbs. That can absolutely act like a smother to this. So there's certain things behaviorally we can do that we know that can boost these levels. And when those levels, you don't have to write any of that down. I'm just saying, you're supposed to eat right, sleep right, and exercise. Like, is that news to any of us? But this is one of the reasons. One of the reasons is because it keeps our growth hormone levels where they need to be. Because we know they decrease with age. We know they do. And when I say with age, guys, I mean you young people too. It starts decreasing, falling off greatly at around 20. So anyway.
So if they want you to sleep enough, I know this sounds funny, but when you have children, it's a known fact that you don't sleep because babies don't always sleep. So do they give you replacement therapies on that? Like, you know what I'm saying? I mean, replacement therapies. Right after you have a baby, you're not going to ever sleep normal again.
Don't tell me something. Don't tell me something.
No, it's true.
That's like somebody coming in and saying, "Oh, if you ever went through childbirth, it's just so hard." No, it's not. It's the best day ever.
I mean, I know they want you to get your 8 hours of sleep and they want you to eat correctly, but then you have factors that.
That's a normal, but that's supposed to be a transient thing. So, it is normal in our life processes that we will go through times where we're not sleeping the right cycles. But that really, once your kids are sleeping through the night, then you should be back.
Does that happen?
As long as they're not in bed with you. Yeah, as long as they're not in bed,
As long as they're not in the house.
Is that why you feel like if I eat too much carbs, I always feel like sluggish?
Yeah, well, it's also something called an alkaline shift that happens. We're talking about this thing, but whenever you eat any meal, you're going to get a pH shift in your bloodstream. So this is any meal. So that's why they do tend to say, we really weren't designed for these huge, big meals because they weren't usually these big restaurants on every corner, right? We've had this, so we kind of lost this portion control thing that in nature we would have had. So like I said, we're in a much better situation than long ago. But on the other hand, we've kind of lost that sense of balance. But it is the alkaline shift that causes you to be tired, but then also this as well.
I always feel that, but then I'll ask Josh, I'm like, does lunch just get you sleepy or sluggish? Because I have no idea.
Yeah, so
How do you not know what
because some people are so sensitive to things. Some women. We haven't talked about melatonin. I told you all in AMP1 about melatonin and serotonin levels, and there's this whole thing. But some people are so sensitive to those changes that they really do, even in the shorter winter seasons of daylight. They're very sensitive to that, and they don't feel like they can function as well. They're so sensitive to it, and it can be a serious thing to their lives. Some women are so sensitive to their estrogen progesterone cycles through the month, through their monthly cycle, that they also have similar types of feelings because they're so sensitive to it. But some women aren't. Some women are so sensitive during menopause that those fluctuations that happen during menopause absolutely, can really affect their quality of life. Or some women will say, oh yeah, I had a few hot flashes. It's no big deal, right? So it's like I said, guys, we're in this thing together, where we're expected to be able to have every answer, every whatever, and be perfect. And it is absurd. It is absurd because there's never two people that are going to be exactly alike. And we are now in a society too that we want everything, a pill to make everything perfect right then. We want, as first grade teachers, for all of our students to sit down and pay attention. Okay, so take that pill so you can sit down in our classroom and pay attention. I know elementary teachers who, for some reason, feel like they know best for children that push parents to get drugs for their kids. And do y'all know any? I'm not the only one, right? So it's wrong. It's so wrong to do because, and we want we want immediately our headache to feel better. We don't want inflammation. We don't want the inconvenience of a fever or a runny nose or pain, right? But guess what? Every one of those things to a point, now those things can be too much, but every one of those things to a point are helpful. But we would have to get through the symptoms. And behavioral things, I'm sorry guys, behavioral things are the answer, not the quick fix chemotherapeutics, because they're usually going to throw something else off. And that sounds like opinion. That's actually chemistry. That truly is. But we really do. How many of you know people who go to physicians and ask for a particular thing and get pissed off if they don't get it? Antibiotics. Yeah, antibiotics is one of those. Pain meds is just a huge one. And absolutely the data supports now that pain meds do nothing really significant for pain. Isn't that horrible?
Yeah.
I have a patient that comes in often. Her husband is a doctor. She will make herself sick so she can get what she wants.
That's a very common thing. I know you're saying that's a very common thing that they will do self-harm just to be able to get someplace to
I've
get.
seen that.
Yeah. No, that's a very common thing. And that's not that person's fault. I want everybody to realize that it's going to be hard sometimes for you to not judge. It's not your fault. The medical community has created this mostly.
There have been people that have gotten placebos thinking they're getting pain meds and don't have pain.
Yeah, the mind is powerful. It's so powerful because that is known that can be. So, it's the same thing with antibiotics. You'll see people who absolutely don't need the antibiotic, but they'll get it. They'll have to get it. And they'll say, oh, but they were so much better after it.
You already human.
Yeah. So
So what do you do? So
it's individual. This is what I'm telling you. You don't, because some people really do need the medical support.
Yeah.
Some people really do need the chemotherapeutics. I mean, they change the course of human existence. You guys still understand that at the end of World War II, when antibiotics were just being beginning to be mass produced and used, antibiotics have saved millions of lives just in this country. So sometimes they really are used. Immunizations. Anybody who thinks that immunizations don't save lives or shouldn't be done, I just have to tell you, there are people who aren't informed enough. They're not well enough informed, and that's just a fact. But tetanus has always been. It's a bacteria.
First case in
Well,
Monks came back to college.
Well, we've had mumps outbreaks, we've had measles outbreaks, we've had an outbreak, but we usually have a very low number of people who die from tetanus in this country because we have DPT, the diphtheria, tetanus, and pertussis shock, or DT. So we have that, but that's always been around. And in other countries, it's a significant cause of death. In the United States, we take so much for granted. We have so much. It's one of the reasons I didn't complain too much about the taxes. I told my sister last night, you did my taxes. I said, that's okay, because I like cops. And I want to pay them, I want them to be here. And roads, and schools. It's okay. So, but the thing in this country we take so for granted, but in other countries, tetanus is it's a significant cause of death. It's an infectious disease. In this country, we don't because of immunizations. People stop getting immunizations, we're going to see the deaths go up.
Well, they're
And it's an avoidable death. It's so avoidable. It's just like measles, encephalitis, where a child's a few cases of people with measles will progress to that. And if they survive, they will have lifelong neurological consequences. People think measles is nothing. That is so wrong. It's almost like we forget history in this country. You know, we think the human situation is so bad right now, but we need to go back and look at some of us, even our grandparents, and what they went through. We've made a lot of strides, and chemotherapy is absolutely necessary, but you can't just be writing for everybody just because somebody comes in and demands it. We've got advertisements on TV from pharmaceutical companies trying to convince lay people without a background to go to their doctors and demand certain meds. We've got now, what is that Roman thing? We've got now people who all you have to do is call up and talk to a doctor, and they'll send you discreetly erectile dysfunction meds in the mail. You know, I'm thinking, like, is this where medicine has come to? Like, everything's on TV. People are doing, they're being advertised for people to use.
Yeah, but
I think we've kind of gone over that, so we should need to come back and not become hippies. I'm not saying become hippies, but and not do. I hope I don't come across that way. Because I think medicine and chemotherapeutics are amazing. It has changed our lives. I would have been dead long ago just because of the lifespan of a human. Even 100 years ago, it wouldn't be likely that your dad and I would be here. Our graduating class would be gone, right? But you get what I'm saying. So there is definitely, but people need to be looked at individually and not be treated as labels. Get a label. Do y'all understand that mental health disorders right now? I have gotten so much off topic. Do y'all want me to stop talking about this? Can I just say one thing?
Yes.
Do y'all understand that mental health disorders now are being diagnosed from people who have like master's degrees from Liberty University before they even see doctors, medical doctors? That they get a labeled diagnosis so that the medical doctors can just write a script. And and when I say liberty, I'm not trying to really diss liberty so much, except that yes, I am. So, and I just am, because I actually know what's coming out of it. So I just need you all to understand that we are just creating this whole little society of writing scripts and labeling and writing scripts for a seed instead of a person. Tell me about your life. Tell me what's going on. Tell me what your routine day is. Tell me what you're doing. And figure out what's really going on. Instead of saying, well, you feel like you got a headache, here's a pill. It's hard. You guys have chosen an amazing field to go into, bless your hearts, because you really, really have. And it's exciting. I'm not trying to make it sound like it's not. It's exciting because you know how much change is going to be happening in just the next decade? And do you know who should be a part of it? Us. You should be a part of pushing that change. Every time you see, do you know most people, and this is most of you all in your generations, where you get most of your news? Social media sites. Marketing, guess where most of that's happening now? Social media sites. Do you know how much misinformation is out there on those sites? A lot. So you guys need to be the readers in this, and it's going to be exciting because I think a lot of things can change. So when you see, and this is a true case, when you see that kindergarten teacher who has 17 out of 20 kids being treated for hyperactivity disorder, 17 out of 20, because in the first 4 weeks she had pushed those parents to get that done, get that testing done, because the counties get more money with those types of labels and whatever. I'm not saying it's all been done for that, but when you see that kind of thing, you change it. You change it, and you push for that kind of change. So it's going to be exciting because we're in the best situation we've ever been. That's all good news, but we can be better. we can be better. And I truly believe that, or I wouldn't be doing what I'm doing. I believe that. All right, so anybody want to comment to that and say you're full of shit? Because it'll be okay if you want to, Nobody wants to know. You think I'd hold it against you, don't you? I wouldn't. These are the hormones. Now, we have gotten all the ones from the pituitary gland, and I think that's actually really good. But I do want to just add a little bit to this, and then I have a little exercise for us. Okay, so we've already talked about the pineal gland, haven't we? Some people call it pineal, but the pineal gland. So we know that when we're looking at a mid-sagittal section of the brain, again, to give you perspective, the corpus callosum is right here. The frontal lobe is here, right? We had the thalamus, the hypothalamus, and then what was this? Good job. And then right dorsal meaning behind, or if you talk about caudal, it means toward the tail, going back to this way. But anyway, so here it is right here, this little area. This gland is called the third eye. Why do we call it the third eye? Because it's sensitive to what? Sunlight. Yes, sunlight, natural sunlight. So we know that this is sensitive to that. And we're on what's called the circadian rhythm of secretion from this gland. Serotonin by day that is converted to what by evening? Melatonin by evening. So we know that we're on this 24-hour cycle that's totally dictated by sunlight and length of the daytime. Serotonin, is it a feel-good neurotransmitter? Is it a hormone in this case? No, it's more for functioning, isn't it? Getting up and functioning. And then obviously that makes you feel better if you can do that, but you get what I'm saying, it's for functioning. And then melatonin is time for rest, right? It's converting to melatonin by evening. You sleep during those dark hours where you wouldn't be able to see anyway, unless we had this artificial electric light. But so melatonin, we're resting, where we're getting that resting pattern that we said is going to rejuvenate so many different things. One of them being today that we talked about your what cycles? Growth hormones, right? So that's just one of the things. So everybody remember this: serotonin functioning on this rhythm with melatonin for what? Rest. And then we remember that there's something called seasonal affective disorder. That means that shorter day length time, like in the winter months in the northern hemisphere, can lead to depression. And when I say depression, I'm putting quotations around it, because is it truly like, it's really a chemical, it's a chemical lack of having enough serotonin, but really having too much melatonin staying around, too much melatonin, and serotonin levels have been also affected. So people get treated for depression by taking drugs that will interact with what? Serotonin levels. So they will try to maintain serotonin longer in the synapses. They will try to keep the reuptake, inhibit the reuptake of serotonin, and that makes it longer in the synapses. So those antidepressant drugs are drugs that are trying to target this particular circadian rhythm. So again, people who don't sleep, they'll end up wanting a pill. What will the pill be? Melatonin. But should we kind of be careful with what we're doing with that and wondering what we're doing with that? Yeah, absolutely. People who are having exposure to lots of lights, like the screen times, can it affect this? We know it can. Yeah, it absolutely can. So again, we understand this. Any questions about this? You'll know what SAD is? Okay, all right, seasonal, okay, there it is. So seasonal affective disorder. So what's really cool? Instead of that melatonin, those pills, how about phototherapy? How about light therapy? We say no to be effective. Is it going to be as quick maybe as a pill? Maybe not, but in the long term, we understand that this is this would not cause any other of those symptoms that other things can. I think this is enough hormones for introduction today. But what I want to do is a little exercise after a break. So how about 15 minutes? We will be out of here by 1 with this break. Before y'all leave today, what I'd like you to do is to, well, there's a little thing I'm going to get you to do with a project. But I'd also like you to be looking at these 10 glands. So the hypothalamus, you know where it is, don't you? Pituitary, the pineal, yes. And then I'm going to want you to look at this. And I think y'all know the gonads, don't you? If you don't, you need to see me after class. Okay, so you know the gonads. And then it's really just 5 others. The adrenals, do we kind of know where those were? Because the name told us where they were. Where are they? Above the kidneys. And then I want you to look at them and just get your idea about those. I also, during lab, want to confirm to you or just show to you exactly, which is studying for that first lab. And anyway, and then we have a little thing that's fun. But 15 minutes, can we do 15 minutes?
Yeah.
All right, thank you so much.
I have a question real quick.
Yes.
So serotonin and melatonin are the only 2 hormones